Okay, let's take a look at some quiz questions because the quiz went not as well as I'd hoped. So we're going to try some of these that gave a lot of people trouble and see if we can't figure out what happened. Alright, so this is 5 and 6, and these were without replacements. Okay, number 5 says probability of plane and plane. Okay, so what it's saying is we want to pick one plane ball out, and then without replacing it, to pick another one. Okay, so the very first time we pick, we see how many plane are there. There are 8 out of a total of 8 plus 4 is 12. Right? And we're going to multiply. So now all we have to consider the second time is that we're not replacing the first one, which means we have to assume one of these got picked. It doesn't matter which one, as long as we take away one. Which means the second time we pick, we don't have 8 favorable outcomes anymore. We only have 7. Okay. We don't have 12 total outcomes because one of those is taken away as well. There's only 11. Right? Then this is just multiplication, but I can simplify 8/12 first. I know that's 2/3 times 7 over 11, and that is 14 over 33. No, wait a minute. Oh, you know what? Hold on. We gotta rewind this back a little bit, as I wrote the problem down wrong. I was wondering why that answer didn't show up, because it says plain and then shaded. Whoops. That changes things a slight amount here. So there are 4 shaded out of, let's still take one away, so that's 11. Okay, we can still simplify this to 2/3. And now this is just 4 11s instead of 7. So this ends up being 8 over 33. And that actually is an answer choice. Okay? So, we did know if we wanted plane and plane, we would have gotten 14 out of 33. Alright, problem 6 said probability of shaded and a second shaded. So, since this is a new problem, put this first one back. Okay. We draw our first ball out. It's shaded. There are 4 of them, so that probability is 4 out of 12. And then since we want a second one, we have to consider that this one didn't go back into the pile. So now there are only 3 shaded remaining out of 11. Okay, again we can simplify this. This is 1/3 times 3 over 11. Again, we talked about this in the last video we did here. We can simplify. If I have 3 and 3, I can divide both of these numbers by 3. So this becomes 1. This becomes 1. And then our answer is just 1 over 11. Okay. If you don't like that method, you could just multiply these and get 3 over 33. And then you'd be like, oh, well, I can simplify both those by 3 and get 1/11. Either way, that's your answer. Okay. Alright, on the back side, these ones went about as bad as could be. So let's try to figure this out. So again, these were without. Oops, if I could spell right, that'd be helpful. Without replacement. So a lot of people are doing all sorts of wacky stuff with this and coming up with their own math, and that was causing you trouble. So first question said, what is the probability of getting a D and an S? Okay. So first we look at what is the probability of getting a D. Well, there's 1, 2, just 2. out of a total of there are 15 letters here. So every time, this first event will always be some number out of 15. Okay, then we multiply. Now before we go to the second number, we have to assume that our first choice we picked a D, which means one of these D's isn't here anymore, which means automatically before we do anything else, I know there's only 14 outcomes remaining. Okay, we want an S, so we look, there's only one S in the whole group here. It's just 1 out of 14. Multiply here. And again, I can see, well, 2 and 14, I can simplify that down to 1 and 7. That makes life easy for me. 1 times 1 is 1. 15 times 7 is 105. So there's a 1 in 105 chance that this will be our result. That's our answer. Okay. Our second one, probability getting a V and a P. Okay, so new question, so everything comes back on the board. First event, we want a V. There's only one V in the group, so that's 1 out of 15. If we pick this one, it means there's only 14 remaining for our second one, and we want that to be a P, and there's only one of those. So this is just 1 out of 14. So 1 times 1 is 1. 15 times 14 is, if I remember this, is 210. Okay, right, because 125, or 225 minus 15, 210. That's your, here's your answer for that one. Okay. Alright, here's where you got, I don't know, maybe a little trickier. So next one says, what's the probability you'll draw 2 consonants, which means we want the probability of a consonant and then another consonant. And we remember that consonants are all of our letters that aren't vowels, so we can mark these off here. Not a vowel. Okay, so that's 5, 6, 7, 8, 9, 10. So we have 10 consonants, which means we have 5 vowels. Alright, so our first pick, our first consonant, there are 10 of them, so that's 10 out of 15. Again, it's always just what's favorable, what we want, over what's possible. Times, again, if we already picked one, we can't pick it again. So if we cross one of the consonants out, it doesn't matter which one, our probability of getting the next one goes down by a little. So there's now 10 consonants, there's just 9. There's not 15 letters, again there's 14. So we can simplify. 10 over 15 is 2/3 times 9 over 14. Again, I can look at it and I can say I can divide both these by 3. And then 2 times, oh, you know what? I can also do 2 and 14 are both even, so this could be 1 and this could be 7. And then my multiplying gets pretty easy because this is 1 over 1, and anything times 1 is just itself, so this is just 3 over 7. That's that. So it says, what is the probability you will not draw a consonant on either of the two draws? Not draw a consonant. There's 2 ways we could write this, and they're both going to end up equating to the same thing. Ugh. So we could say the probability of not consonant and not consonant. That's a little bit wordy though. We said if a letter is not a consonant, it has to be a vowel. So another way of writing this would just be to say, what is probability getting a vowel and a vowel? Okay. We're saying we will not draw a consonant. There's only 2 options, right? So you said there's 5 vowels, so our first chance is 5 out of 15, just like every other time. If we pick a vowel, we can't pick it again, so that goes away, which means there's only 4 for the second event, so 4 out of 14. We multiply these together, or actually we can simplify first. This is 1 over 3. 4 over 14 is 2 sevenths. Okay. And then this just multiplies, this gives us 2 over 21. So that's our chance of getting 2 vowels in a row. Alright, and then our last one for this set of questions. What is the probability of an N and then another N? Okay. So we want to pick an N the first time. We see 1, 2, 3 N's. We get 3 out of 15. Problem I saw is a lot of people put 3 out of 15 and they simplified it and they put 1/5 and they just circled it. That was it. But you just ignored the fact that we wanted to pick 2 of them in a row, which is kind of bad, right? We got to consider what is the probability of getting a second one. So just like before, we pick it once, we can't pick it again if we're not replacing it. So there are only 2 N's remaining out of 14 total choices. Simplify, 2 over 14 is 1 out of 7. Multiply these together, this is 1 out of 35. That's that. Okay. Alright, the next set. Now some people are asking me because it doesn't specify, do we replace or do we not? The fact is, on this one, it doesn't matter if we put it back or not. Mostly because all we're doing is we're picking 1 from this group and 1 from that group. So whether or not we put it back doesn't matter. Okay? The only time it matters if we said if we're picking 2 from this group, or well, 2 or more from this group. But if we're just taking 1 of each, it doesn't matter if we put it back. Okay, so let's see. First one is probability of 42 and a star. Okay, so 42, there are 2 42s here out of 10. So there are 10 numbers here. And there are 4, 9, 12 shapes here. Make sure I drew it correctly. 12 shapes. Right. So 2 out of 10 is a chance of getting a 42. And to get a star out of the bowl, we'd say there are 12 shapes here. Only 4 of them are stars. So that's 4 out of 12. Okay. So then we're multiplying these together. We simplify. So 1 over 5. 4 over 12 is 1 over 3. And then 1/5 times 1/3 is just 1/15. Let's see. That's all there is to it. Alright, next one. Probability of 7 and arrow. Okay, so this time there are 3 7s. And there are, I'm sorry, I didn't mean to do that. Not 3 out of 7, it's 3 out of 10. Right? Always 10 numbers. Arrow, 3 arrows out of 12. We simplify. Can't simplify 3/10, we leave that, but 3/12 is 1 over 4. So this just gives us 3 over 40. Let's do one more of these. So 15 says find the probability of not getting an odd and not an arrow. Okay, so not odd essentially just means even. So we look which of our numbers are even. 1, 2, 3, 4, 5. Well, that's not too bad, right? 5 out of 10. We say how many of our shapes are not arrows? Well, these 4 stars are not arrows, and these 5 hearts are not arrows. So that's a total of 9 out of 12. Simplify these. 5 tenths is 1 over 2. 9 twelfths is 3 over 4. Something here. Hold on. Oh my goodness. Maybe it would help if I could count correctly here. Oops. Our even numbers, I should probably count 4 as being an even number since it is. So this actually isn't 5 out of 10, but rather 6 out of 10, which changes this number a little bit. Got me a little worried. I thought I had the wrong answer, and then I would have to go back and change everyone's grade. Okay, so 3/5 times 3/4. This gives us 9 out of 20. That looks correct. Alright, sorry. That was confusing. I didn't. Okay. Number 17. In a deck of cards, 2 are drawn. What is the probability both are red? Probability red and red. Okay. So what can make this problem difficult if you're not used to it, I suppose, is whether or not this is independent or dependent, meaning does the chance of the second one being red depend on the first? Okay. And we consider about the small difference in percentage of this. It's hard to tell just from looking at the answers. So what we can do to help clarify the situation about picking 2 cards at once is to take a different example. Okay, so let's consider 17b, which isn't a real problem. If we say, what is the probability of the ace of spades and the ace of spades? Okay, so again, same situation. If we say if we draw 2 cards on the deck, what is the probability both of them will be the ace of spades? And we'll look at it in 2 different ways. So if we say these are independent, okay, we'd say one event doesn't change the other. So we'd say there's 1 ace of spades out of 52. Okay, and then we would say, drawing it again would still be 1 out of 52. But does that make sense? If it says we draw 2 cards from the deck, is it possible that in those 2 cards, if you flip them both over, that they will both be the ace of spades? No, that's literally impossible because there's only one of them. So this cannot be an independent event. This has to be a dependent event, which means that in this case, chance of getting ace of spades the first time is 1 out of 52. That's correct. But the chance of it coming up the second time is 0 out of 51, which means the probability of this event happening is exactly 0%. Okay? And that's how drawing cards works. It's always going to be this way. The second card will always depend on the first. Okay? If you're picking 2 cards out, one affects the other. Okay? So coming back here, cannot just say 1/2 times 1/2. As easy as that sounds, put 1/4. That's not correct. Okay, it's not going to be correct. Okay, probability both are red. Yes, the first time is 1/2. 26 out of 52 is 1/2. Second time isn't though. If you had 26 red cards, if you pick one, there is now only 25 red cards. Okay, so the second card is going to be 25 out of 51. Okay, which gives us a probability of 25 over 102. And there's your answer. Okay. Alright, one more. Puppies. If you ever want to feel better, okay, about anything, just go on Google, right? Google.com and type the word puppy into the search box, okay, and you will automatically feel better. Feel free to pause and do that now. Okay, but I looked up 9 puppies because our question said if you have 9 puppies and 4 of them are black, what's the probability that that the first 2 puppies open their eyes will be black? Okay, so I found this picture of 9 puppies and it was almost perfect, except we only had 3, so I colored one in here. Right, so we have our 4 black puppies and our 5 different colored puppies. Okay, so we want probability of black and black. Okay. So now again, we got to think it doesn't specify is this independent or dependent. Okay. But if you're picking 2 of them, okay, and we're not even picking them, it's just saying they open their eyes. So what is the chance that the first dog that opens his eyes will be one of the black dogs? Okay, so we say there are 4 of them out of 9. And that's easy enough. Sad thing is, some people put this as their answer. They got 4 nights and that was it. They were done. Okay, they ignored the whole second part going on here. Okay, so for our second event, we have to consider what's left. If we say this dog opened its eyes first, okay, there it is, eyes open. Can that be the second dog to open its eyes? No, this one's already done. We can't pick it again. So this one goes away. So we look at what's left. It's not 4 anymore. There's just 3 black puppies out of a total of 9 minus 1 is 8. Alright, then we just do our math. This simplifies down to 1 over 2. 3/9. I can simplify that to 1 and 3. And then I just have 1/3 times 1/2, which is just 1 over 6. And that's it. Alright, so we're going to keep practicing this. Hopefully this makes a little bit more sense now. Alright, good night.